Hello. Welcome to Kubernetes Architecture. Today we'll explore the key components that make up a Kubernetes cluster. Kubernetes follows a master-slave architecture with control plane components and worker nodes. The control plane manages the cluster, while worker nodes run the containerized applications. Let's start with the control plane, also known as the master node. This is the brain of the Kubernetes cluster, responsible for managing the entire system. The control plane consists of several key components that work together to manage the cluster state. Let's look at each one. Now let's look at worker nodes, which are the machines where your applications actually run. These nodes receive instructions from the control plane and execute the work. Each worker node has several components that help manage and run containers. Let's examine these components. Let's now visualize how these components work together in a complete Kubernetes cluster. Architecture. At the top, we have the control plane, shown here in red, which manages the entire cluster. Below the control plane, we have worker nodes, shown here in green, where containerized applications run. Inside the control plane, we have several key components. At the top left is the API server, which serves as the front end for the Kubernetes control plane. It exposes the Kubernetes API and handles all communication between different components. Next to the API server is etcd, which is a consistent and highly available key-value store used as Kubernetes backing store for all cluster data. It stores the configuration data, state and metadata of the cluster. Below the API server is the scheduler, responsible for assigning pods to nodes. It watches for newly created pods that have no assigned node, and selects a node for them based on resource availability and other constraints. Finally, we have the controller manager, which runs controller processes. It manages different controllers that regulate the state of the cluster, such as the node controller, replication controller, and endpoints controller. Now let's examine the components inside each worker node. On the first worker node at the top left, we have the kubelay, shown here with a K. The kubelay is the primary node agent that ensures containers are running in a pod. Next to the kubelay is the kube proxy, shown with a P. This network proxy runs on each node and maintains network rules that allow communication to pods from inside or outside the cluster. At the bottom of the first worker node, we have two pods represented by blue circles with Ps. Pods are the smallest deployable units in Kubernetes and can contain one or more containers that share storage and network resources. The second worker node has similar components: a kubelay, a kube proxy, and a pod. This shows how each worker node has the same basic components to manage containerized applications. This architecture allows the control plane to manage the cluster effectively, while worker nodes run the applications. Communication between all components happens primarily through the API server. ensuring a consistent and reliable system. Let's clear the diagram and summarize what we've learned about Kubernetes architecture. In summary, Kubernetes follows a master-slave architecture. The control plane manages the cluster state. Worker nodes run the containerized applications. And all components communicate through the API server. This architecture provides a scalable and reliable platform for deploying and managing containerized applications.